Hi guys, welcome back to In Case of Econ Struggles. Welcome to another micro struggle. Today I'm going to talk about the present value of money. I'm going to talk about intertemporal choice. I'm going to talk about warp and how warp factors into intertemporal choice. So timestamps are below if you would like to jump around, but let's go ahead and get right into it. So what I want to start with in this video is the present value of money. And so what we're saying is that here's Bill, and Bill's got a piggy bank. Maybe it's an actual bank that he deposits money into so that he gets interest on whatever he puts in the bank. So next year, he's got more money in the bank just because he gets interest on the money he puts in the bank. And then in 2 years, he's got even more money in his piggy bank because his piggy bank keeps paying him interest. And so we have two questions based on this sort of situation, where the first question is, what is Bill's savings worth after 1 year or 2 years? What exactly is that dollar amount? And two, how much should Bill save today to have $100 a year from now or 2 years from now? So those are the two questions we're going to answer. And what we're going to say is that each year Bill gets an interest rate R on his deposits, or the amount of money that he puts in the piggy bank. So if he puts, P dollars into his piggy bank today, tomorrow he's going to have P dollars, plus he's going to have P times R, where this is the interest that he gets on that money. And so we're just going to simplify that as P times 1 plus R. So just again, in case you missed that, after a year, Bill gets P, but he also gets the interest on the amount of money in the bank. So that's going to be R times P, where this is the interest rate, this is the amount of money, so this is the interest payment he gets. And I'm just going to factor that into P times 1 plus R, which is what I get right here. Now, after another year, we're going to have P times 1 plus R plus P times 1 plus R times R. So now what we're going to have is I can factor this again, but now I can factor this into P times 1 plus R times 1 plus R, which is going to be P times 1 plus R quantity squared, which is what you can see written in small letters in this piggy bank right here. And so now let's just generalize this because you can probably start to see the pattern. And if you're having trouble seeing the pattern, definitely leave a comment below. So what we had is that today we have P dollars, tomorrow we have P times 1 plus R dollars, in 2 years we have P times 1 plus R squared. In 3 years, again, we're going to multiply this amount by 1 plus R, which means we're going to have P times 1 plus R to the third, which means after T years, we're going to have P times 1 plus R to the T, because that pattern that you see in years 1 through 3 is just going to keep going. So in T years, I just have P times 1 plus R to the T. And that's how I can figure out how much money I'll have T years from now if I put P dollars in the bank today. Now suppose instead of putting P dollars in the bank today and asking how much it's worth in T years, suppose that Bill is trying to think about how much he needs to put in the bank today in order to have $100 60 years from now. Well, we know that this $100 is basically going to be equal to X times 1 plus R to the 60, because that's how many periods away it is, where this is what I don't know. I don't know how many dollars to put in the bank today. So I'm just going to solve this for X. And I'm just going to say this is $100 divided by 1 plus R to the 60 is equal to X. If you don't see that, you can think about it this way. At 59 years, how much money would you need to have $100 in one more year? Well, what you would need is you would need to be at 100 over 1 plus R. Because that would tell you that what's going to happen is that when you multiply this by 1 plus R to go to 60, the 1 plus R's will cancel and you'll just have $100. So that means that 58 years you're going to need 100 over 1 plus R squared, which means that at 2 years what you're going to need is you're going to need $100 over 1 plus R to the 58, because you have 58 years remaining until you get to 60 years. Which means that at 1 year, you need 100 over 1 plus R to the 59, which means that at time 0, you need 100 over 1 plus R to the 60. So that's just how you can go between future value and present value, where this is future value and this is present value, and you're using 1 plus R raised to the exponent of number of periods in order to tell you either how much something's going to be worth in future dollars, or how much you need to put in the bank today in order to have some value in the future, as well as how much money a certain dollar amount you put in the bank today is going to be worth in T years. So again, if that's confusing, leave a comment below, but let's now move on to intertemporal choice. Now for intertemporal choice, this is sort of the setup. again, we have Bill. Bill has 2 stages of life. He can be young and he can be old. Those are like the 2 stages rather than split it up into different ages. And we're going to say that Bill has an inheritance or an endowment. And that's the only money that Bill has over the course of his life. And so what he can do with that money is he can buy stuff from the store or he can put it into the bank. And so he can either save or consume. And of course, his savings plus his consumption must be equal to his endowment. And our interest rate is going to be R. So what we have is we're going to have this guy right here, where this is a graph just showing how much Bill wants to spend when he's young and how much he wants to spend when he's old. Because of course, what he doesn't spend when he's young is going to go into savings, and that's going to turn into 1 plus R times his savings. So this is sort of his intertemporal budget constraint. So what we have here is that this is how much Bill could buy when he's old. If he doesn't spend anything when he's young, he puts all of his money into the bank, and so he has 1 plus RW, or the endowment, tomorrow, or when he's old. And this red point right here is what happens if Bill decides to just blow all his money right now when he's young. He's going to have nothing for when he's old. He's going to spend it all today and have nothing for tomorrow. And this line is basically everything in between. Now, one thing to note about this slope is this just going to be negative 1 plus R, because that's the trade-off for Bill between spending today and spending tomorrow. For every dollar that he doesn't spend today, he's going to get 1 plus R dollars tomorrow in order to spend when he's old. And so we just take the negative of that, and that's the slope of this intertemporal budget constraint. Again, if that's confusing, leave a comment below, ask a question, and I'll try to help you out. Now, let's suppose that we just make this a little simpler. So let's just call when he's young today, and when he's old tomorrow, or T plus 1. And let's say that maybe he gets an endowment in both periods. Maybe he gets a little bit when he's young and a little bit when he's old. And so here's the endowment, WT plus 1, or omega if you want to be fancy about it. Again, this budget constraint has a slope of negative 1 plus R, and it's going to go through the endowment because Bill must be able to afford the endowment. Because if you give him stuff, he must be able to afford that stuff. That makes a lot of sense. So now what we're trying to think about is how Bill can make his decision in order to figure out how much to spend and how much to save today. And what we're going to do specifically is talk about how this relates to warp. And so let's really quickly talk about warp. So here's what warp is. Warp is the weak axiom of revealed preference. And so what I'm going to say is I'm going to say that here's an example where Bill violates warp, because I think it's easiest to sort of get the idea of warp if you see a violation. The basic idea of warp is you want to be internally consistent. So let's do an example in which Bill is definitely not internally consistent. So here's the story. Bill's hanging out at a restaurant. Will, the waiter, comes over, gives him a menu. It's got 2 options, A and B. I don't know what A or B are. Pick your 2 favorite foods at a restaurant. But Bill basically says, I will have option A. Well, the waiter says, great. He goes to the kitchen. He comes back. He comes up to Bill and he says, I'm so sorry. I totally forgot. We also have option C today. Again, I don't know what option C is, but there's a third option. Maybe it's a special or something. And Will's like, would you like to change your order? And Bill says, actually, I would. Now that option C is available, I would really like menu option B. And you're like, I mean, I've seen this happen in restaurants, but it doesn't seem rational. It seems sort of weird. And here's why it's weird. It's weird because when you made the first choice, when you picked A, when you had options A or B, you basically sort of said, well, A is weakly preferred to B. If you recall preference relations, you basically chose A over B. And then when you had 3 options, A, B, and C, you chose B. And this basically said that B is weakly preferred to A, which is like, this is weird. This is a warp violation. You could have chosen B right here, but you didn't. You chose option A, and then you switched when some third option that wasn't really relevant came into the picture. That's a warp violation. That's strange. And so we call it a violation of warp because you're not being rational. You're violating the weak axiom of revealed preference. Now, how does this apply to intertemporal choice? This is going to apply to intertemporal choice because suppose that you have 2 different interest rates, and suppose that you first start with interest rate A. And so when you have interest rate A, this is your preferred bundle. You prefer this CT star, CT plus 1 star. I don't know what it is, but this is what you prefer. Now notice that because you chose CT plus 1, the options you had available to you were basically all the options under this budget constraint or on it. So this shaded area, which I'm sort of just highlighting really quickly and not doing a great job, this whole highlighted area are options that you could have picked before but chose not to because they were affordable to you, but you didn't choose them. Instead, you chose that pink point, CT plus 1. So now what's going to happen is if the interest rate were to change and become this blue line right here, which maybe I'll just draw again just so it's a little brighter. So here's this blue line. This is the new interest rate. If you choose basically anything that was available to you before, you're violating warp. Because if you choose anything that was affordable to you before, but you didn't choose it, why should you choose it now just because the interest rate switched? So basically, any area in this green triangle is going to be bad. Well, of course, you can't choose anything in here anyway because it's not affordable to you. But anything under this blue line and under the green line is going to be a warp violation. So maybe I'll just highlight that in red. It's probably not going to look very good. But these are all the options that if you pick would violate warp because you could have picked them before but you didn't. And all of these bundles under the blue line but sort of above the green line, these options were not affordable to you before because the interest rate didn't allow you to pick them. So if you pick anything on this blue line or in this green region, you will not be violating warp. And so that's the main way I've sort of seen warp come in with intertemporal choice. And so I thought it'd be useful to go through this graph and talk about it. So if this was helpful, either in terms of the present value of money or intertemporal choice or warp, please like and subscribe. If you still got questions, leave a comment below. But we'll see you next time for another case of Econ struggles.